So, I'm an open source architect at Talend. We create integration software. Talend USB is a product on OSGi that is very related to this talk. We also fit in the big data space. So, a lot will be also presented this week at Apache Camel, where I'm heading afterwards. So, my talk is about lean microservices on OSGi. So, what you can do later, you can participate in the demo. Hope you have enough time. Let the free know, channel OSGi chat. Not necessary, but you can. So, let's start with microservices. What is the definition? It's very big in the industry right now. The question is why, and let's look first at what it is. It's a way of designing software applications as suites of independently deployable services. It's organized around business capabilities, automated deployment, intelligence and endpoints, decentralized control of languages and data. So basically, it's about separating your application into modules and making them deployable and developable independently. So typically, this is one service per process. That's how it's done in most cases right now. It's not what I show, but that's a typical limitation. And it's typically communication using REST or sometimes messaging. Very important is it's about the business capabilities. So you're not separating in layers, in technical layers. You're separating in business capabilities, and one service always goes from UI down to the database or whatever your persistence is. The most prominent framework today for doing microservices is Spring Boot. It's meant for microservice development, but it kind of can only do microservices. It's very easy to start. You just put some snippets together and are ready. It's convention over configuration, so you can start without much configuration and can add as necessary. And it's got good Docker and cloud support. So what I try later is to look into OSGi to see what we can do with that and have a lot of the good features that are in Spring Boot also in the OSGi world. In Spring Boot, there is also a dark side that's showing of the microservices. Or like Yoda was once asked, are microservices stronger than OSGi? And he said, no, quicker, easier, more seductive. So what I want to show is that it can easily put you on the wrong way, and it's difficult to turn around then. One big thing is dependencies between microservices. Theoretically, you would make microservices as independent as possible, but in reality, it's more like this. You have a real graph of microservices all using each other, and if they're very decoupled from their development, you often don't know really how they are coupled and what the dependencies are altogether. So that can be really dangerous. There's also operations. In good old days of application service, operations was a bit like this container vessel. It's a bit slow, a bit bulky, but you have one guy that steers the whole ship, and it's easy to steer, kind of. It's slow, but it's easy to steer. Microservices, in theory, look like this: a fully automized harbor where these trolleys go all to the right places at the right time. But in practice, it's often more like that. So that's how containers were processed in remote islands when they don't have the harbor facilities for containers. They just use what they have and tow things together and do their best. So that's operations today most of the time. It's also, microservices cannot cure bad design. So if you have a big shitty monolith and you separate it into microservices, you have a lot of big shitty small monoliths. So it's not really better if you just split it up and don't improve the modularity. Also, Spring Boot, it's it looks like a good solution if you start, but it can easily grow into something that is not so well manageable anymore. One big thing is if you look at the Maven dependencies and you just add what Spring Boot guys tell you, you get a lot of dependencies, and you always get them at design time. So you open your project, you have all these classes at your hands, and what do the developers do? They use them all. So you cannot limit what they use. Also, as microservices in the Spring Boot sense are normally deployed in one process each, they always have to communicate remotely. And remote communication is distributed computing, and that's always high complexity. There's so many things that can go wrong, and it's difficult to do right. There's also, most of the Spring annotations are proprietary. It's Spring annotations, they follow no standard. So once you go that way, you go the Spring way, and it's difficult to change it later. The same thing about the packaging. It's always this thing, one service, one microservice, one deployment unit. You cannot really put flexibly several services together if you want to. You will always have to do them one service per process, one service per deployment unit. It's good when you're really big and you need that flexibility to develop each service on their own. But normally you're not that big, especially in the start, and it's a high overhead from the start. Even if Spring Boot starts easy, so it's easy to start with, but once you develop your functionality on it, it's really complicated to make all that work together. A small Spring Boot project typically has around 90 dependencies, at minimum 20 MB jar file, and that's just to start. There's a lot more if you do real things. So all that pollutes the class path, and it's difficult to tell your developers which APIs they should use to limit the coupling and which they should not use, because they have all on the class path and tend to use what they have. If they see a nice class, they use it. So how is OSGi different? We just heard in the keynotes about the APIs and the OSGi services, and that's exactly the thing you're looking for. As an OSGi developer, you have your small project that makes one bundle. You code ideally just against APIs in your dependencies in Maven, and ideally even specs, not proprietary APIs. So you have a much more limited dependency tree, ideally just one level to the specs and not further. And you create these bundles that self-describe themselves. They tell you what they need, tell what they provide. So it's easier to document what they need. It's self-documenting. And you have these services to communicate between each other. So the bundles just depend on interfaces and say, I need a service that satisfies this interface. And that's how you can make things more loosely coupled. You also have semantic versioning. I'll show that just a slide later. And there is a remote service admin. It's an OSGi spec that allows you to communicate over boundaries of one framework, one process between also nodes. So that's ideally the way to communicate between services. And the packaging is flexible, like Peter explained. You have these requirements on capabilities on each bundle, and with the resolver, you can put them together as you need. So you're not limited to the way Spring Boot does it. One service, one deployment unit. You can do it as you see fit. Semantic versioning is a very important thing because your APIs evolve. So you have to keep track on how these changes are done. And you have the typical versions syntax like major, minor, bug fix. Normally it's often just a marketing thing. So cool new functionality, we do a new major release. That's not the way you should do it in OSGi. If you version APIs, you should use semantic versioning, which means just use a major version if you have incompatible changes, but then you must, and minor version if you just add functionality. And The nice thing is that there are Maven plugins and other plugins for BND where you can automatically check this versioning. So if you change something, it tells you that you should increase, for example, your major version. Then there's remote service admin. That's a way to communicate between bundles. OSGi services by themselves are just a way to communicate inside a framework, inside one process. And remote service admin allows you to communicate over the boundary. So basically, it's working based on OSGi services. So if you want to provide a service to the outside world, you just export an OSGi service like you would do locally. Just give it some special properties. And so the remote service admin knows, oh, I need to pick up that service and make it publicly available in the way that is described in these properties. So there you can define which transport to use and how to configure that transport. It's also nice that remote service admin has this topology manager in the middle. That's the way to define also policies. So if you have you develop software for a big company, you can say a certain set of services should have certain security constraints, like it must be SSL, it must use a client certificate, the consumer must use a client certificate for authentication. You can define those policies centrally and just say, I need this level of service high security. And then a remote service admin takes care of providing that security. You also have exchangeable part at remote service admin. That's the way to export and import the service. So you could have a binary transport, you could have REST, you could have SOAP. Just exchange the remote service admin part and you get a new one. The same with discovery. So what I show is with Zookeeper discovery, but you also have other discovery mechanisms available. Like I just mentioned, you can also do REST with a remote service admin. You just use JAX-REST annotations on your interface and mark it as using the CXF transport for RSA with REST. And then you just publish your OSGi service, and CXF creates your endpoint without your user bundle having a direct dependency, for example, to CXF. So let's see that in practice. I've prepared a small chat application. It's just the smallest thing you can show, and provide modules that implement and use this interface in different ways, and they talk to each other using one interface, chat listener. And this is described in an API bundle, and all the other bundles just depend on this API bundle. And of course, they depend on the technology they use for their own implementation. So there's one implementation for IRC. That means we're chatting over the IRC channel. There's one integration with a shell, the GoGo shell on OSGi. So you can send a message and see the message on the shell. There's also, oh, I didn't prepare that. There's also the Tinkerforge display and motion detector that receives the chat messages, shows it on the display, and the motion detector can detect motion and show it as a message. And we have optional remoting using RSA. So we can do it together or remote. So the first thing to show is all-in-one. There we use just one OSGi framework. We have the chat API, the shell integration, the Tinkerforge adapter, and the IRC connector. It's just one process. The runnable jar is 6 MB, so the whole thing is smaller than the start for Spring Boot, and it's also already including, for example, Apache Camel, the Tinkerforge drivers, and all together. There are no remote calls, so it's really a simple application in that regard, and it's the way you can start. And still, these modules are separated from each other and just communicate over OSGi services. So the same modules can be used later for a more complicated setup. So this is still, from a deployment perspective, still the container vessel. So it's just one thing to deploy, one thing to steer. It's easy. Then we have the microservices deployment. There we go really in the direction that typical microservices follow. So this can, for example, also live in the cloud. In fact, the Zookeeper I show is on Docker, and all the other modules can also be deployed as Docker containers. So there, each implementation lives in its own process, and they communicate using remote service admin. In that case, a binary TCP transport to make it really simple. And the discovery is over Zookeeper, so each service registers with Zookeeper and can be found over Zookeeper. So this is very similar to a real microservice deployment in the cloud. So here we have the same bundles as before. The nice thing is we don't change anything in the development, so the bundles are exactly the same. We can have as many deployments units as needed, so we can scale each service on its own. And we can run on Docker. And the native output is a runnable jar, so it's like Spring Boot from the run perspective. The overhead for a remote service admin is just 300 kilobyte and 800 kilobyte for Zookeeper if we need it. We just use remote calls where it's remote. We can put things together and then they use just local calls. And we have many options for remoting. So in this case, I show the simplest, but we can also use a fast bin transport from Red Hat that they used in Fabricate. And we can use SOAP, we can use REST, we can use JMS, so we can scale. So, but beware, as soon as we go microservices with our OSGi setup, we have the same operation issues as other microservice teams. But the nice thing is we don't have to. We can start small. So let's see that in practice. Unfortunately, I forgot to connect the Tinkerfor stuff. I hope that is working. So. So let's see. So first show the API. That's very simple. Chat listener is just a simple Java interface. Chat message just has some properties, typical data transfer object. And chat broker, that's the way to send messages. It just uses declarative services to announce itself as an OSGi service. It references all the other chat listeners. And then when you send a message to it, it sends the message to all the listeners in parallel. So that's also quite simple. Then I show one of the implementations, the shell one. It's the chat command. So for the command, we also export an OSGi service, say it's a scope chat and command send. And when we get a message in, we send it to the broker and create a message from this string that's coming over the shell. And yeah, and it references the chat broker service. And the shell listener is exporting itself as a chat listener type service. It's telling, using this, basically for what we need, just this, to say this is a remote service. Let this be callable remotely. And this would be needed when we want to make it a SOAP service. What this does is, if it's called, it's just printing out, and this goes to the shell. So this is the shell integration, and similarly we have the IRC integration with Camel, which sends out, it's configurable, and it sends out over a Camel route from the IRC URI with a converter to our broker. So what comes in from IRC is sent to the chat broker. And on the other side, when we receive a message, we send it through Camel to the IRC URI. So this is going to the IRC channel. So let's look at this. I start with this packaging all. This is using bndtools. So we create an index in, where is it, in this project. So basically we use a POM file to define our runtime dependency or our set. It's like a target platform in PDE. So we say what we could need altogether, but this is not actually what is deployed. It's just a set of things we could use. And this is forming this index, and there we put these root bundles where you say, this is what we really want, and give us everything that is needed for this setup. And the resolver gives us then the full list of bundles to run, and this is automatically created when I click the resolve button. So I can run this, and it runs inside Eclipse now. I can also set breakpoints on it. So the shell already, the Tinkerforce display already tells me motion detected, which comes from this motion detector, and sends it as a chat message. This should also, yeah, it also connects to IRC, says motion detected. I can, no, not send. I can just say hi on IRC and see it here on the shell, and also see it on the display. Oh, now it says again motion detected because we can see from who the message comes and hi. So we see it's all connected together, but it's each bundle just knows about the chat listener interface. They don't know that all these technologies have to work together. Oh, we have some guy on IRC. Hello world. So this should also show here. It's not showing at the moment because I scrolled back. But we see it on the shell, and I can also write in bed. I have to put it. So this is a bit strange because it uses ANSI characters, and the Eclipse console unfortunately can't really work with them. This is how we use it directly from Eclipse. We can also build this whole thing. Where is it? I just say maven clean install. And this is quite new. There is now an integration with, between bndtools and Maven. So we can have one Maven build that builds our bundles completely and also packages all our different ways we package this. So the whole build was just 7 seconds, so we see it's quite fast. Now we can run this in this small packagings, like in packaging display, we package together just for the Tinkerforge and the shell integration. We can start this. Now we see arrows about Zookeeper, because it sees there is no Zookeeper present, which means we need to start Zookeeper from Docker. And now it finds Zookeeper. We can see the endpoints. This is from RS Remote Service Admin. We see which endpoints are available. We have one shell listener, one LCD writer, one for this, one for our shell. We have nothing about IRC. And of course, this means we don't see anything that comes from here. I type something and it's not visible here. Now I can add the IRC connector. This is just running IRC and shell integration, not the display. We now can see on endpoints that we got some new. So this new process brings 2 new endpoints. It's a bit difficult to see them because they run on the same IP address, just have different ports. So we see now Tinkerbot joins the IRC channel in the first process. This process has nothing to do with IRC, but using these remote services, it gets everything from the other process. So again, I can send hi to the other side, and it's coming on the IRC display. So we see we can package all together in one process, or we can split out the services as microservices that we want to have split out. We can just split out these where we need quicker deployment cycles or different teams working on the code. We don't have to go all the way up front. We can start small. So let's go back into the presentation. So we can really see how OSGi can scale. We saw the whole packaging all together, including the OSGi framework, Camel, Tinkerforge, adapter, GoGo shell, all together. Not RSA, that's not present there. All together, just 6 MB. And we can also go to microservices, where each deployment unit in that case was about 9 MB or 8 MB. So it's very small. It's very fast, as we saw. Startup time about 1 second or less. And so basically, if you're not sure if you need microservices from the start, but you think maybe at some point we need it, you should not start microservice right now. You should start now creating a modular application that runs in one process, in one deployment unit, but you create it, ideally with OSGi, using bundles that are loosely coupled and can be deployed to different machines. And then you can, at a very late time, say, okay, now I need to split out some of the services and run them in a microservice way, run them on the cloud. But you don't have to start that way. You can start small. Operations will just have one thing to deploy. It's really easy. And you can then migrate the way you really need, not full way microservice up front. Yeah. And so the idea is deploy only as fine granular as needed. Put as many things together in a modular way into one process as long as you can, because that's so much easier to debug. And having no network connections is so much easier to have in production also, because calling another OSGi service rarely fails. Calling a service over REST, where the machine may not be present, where discovery may not be present or be halfway present, can have so many failure conditions. And so you can really start small and then scale. I also got some further reading. Talk from Achim Nierek, Microservices on OSGi, where he shows a similar thing, not fully automated. So it was a bit earlier. From Milan, who is also here today, microservice and modularity. He tells a lot more than me about where microservices are good, where they are bad, how, what risks they have. There's also a link to the OSGi chat example code. All this stuff is on GitHub. You can just check it out, compile it, run it. Should be no problem. And also have another example where I show really how to export a REST endpoint using RSA and CXF DOSGi, which is a typical requirement that many people have, because what I showed was a binary transport. This is not what you typically use in production. Typically, you want REST at some point. So, yep, that's all. Questions?
Hello, I'm Sergey from Imacom. I have a question about the security between the communication between the services, how I can ensure the security between the services.
What I showed right now has no security, but you can put in the security level you need. So, for example, at the CXF DOSGi website, there is an example using SSL on the server side with a server certificate and requiring a client certificate. There's basic authentication, at least with the Apache Karaf server. We also have an integration with JARS. So you can say basic authentication against an LDAP directory or even Kerberos authentication. So you can scale all the way.
Hello. So we learned that OSGi is bind to API descriptions and so on, and the resolver takes the appropriate library which I need. But sometimes API describes it not fully, and then the library is not doing what I want, and I know there's another library. How is that solved in that resolver then?
There are different ways you can approach that. One thing is to have additional requirements that you add to your bundle and add a capability to the library. So you can say, for example, declarative services does that. So if you use declarative services, then the Maven bundle plugin automatically creates a requirement for declarative services runtime, and the runtime says, I provide that capability. So that's more than packages or services, it's arbitrary requirements and capabilities that can also be matched. And the other way is to just include in your index the things you want to have. So you don't include all the world, you just select a set of technologies that you want to combine, and then the resolver can work on a good foundation.